Here we are in Chapter 8, Section 2, Number 5. So compute the value of the test statistic for the indicated test based upon the information given. So the key thing on our test statistic at this point is knowing which one to use here. We're talking about means. See those all through A, B, C, and D. And we have a mean, and we have the key for our test statistic is, do we know or do we not know our standard deviation? That's where we have a distinction. So in each of these, let's see, I'm glancing there as well. The ends are all 30 or greater. That means we're doing the large sample size test statistics. So we can look there to see what those are. So for A, we've got, let's see, our test statistic. It's hard for me to even say that. So we've got our X bar and all these minus our mu naught, our null hypothesis. And since we don't know the standard deviation in this case, we're going to use S, our sample standard deviation, done by the square root of n. So this is going to be 75.1 minus our null hypothesis mean divided by our sample standard deviation, and that's over the square root of our sample size, which is 55, and this comes out to be 2.235. Okay, for B, so we're still doing the same thing here. We're going to be doing our mean, our z value of this as well, and we're going to be looking at the x bar minus mu naught. So depending here, let's see, this one we know our standard deviation, so we want to use that. So our standard deviation over the square root of n. So our x bar in this case is 58.5. Our mu naught, our null hypothesis mean is 58. Our standard deviation, actual standard deviation of the process is 1.22. And divide by the square root of our sample size, which is 40. And when we work all that out, we get 2.592. Continuing on, since we noted these are all going to be means, we'll be developing a z statistic with our x bar minus our mu naught, or null hypothesis mean. And in this case, we need to look again, and it says our standard deviation is unknown, so we're using our sample standard deviation. We already checked on sample size, so those were all larger than 30. So let's see, our sample standard deviation is our sample mean, 23.2, minus our null hypothesis. The mean there was minus 19.5. Our standard deviation, our sample standard deviation is 9.55. divided by the square root of our sample size, which is 30, right at that level, which allows us to be a large sample size. 1 is 2.122 is what we have here. And then for D, continuing in the same fashion, we've got our Z, it's going to be our x bar minus our mu. In this case, we go to see, do we know the standard deviation? We do. And so it's our standard deviation divided by the square root of our sample size. And let's see, here we have 818 as our sample standard deviation. 805 is the null hypothesis mean. I just said 818 is our standard deviation. It's not. 818 is our sample mean. I've got standard deviation on the brain for right now. Okay, so our actual population standard deviation is 37.5. And we're going to divide that by the square root of our sample size, which was 75. And this works out to be 3.002. Now notice that the type of tests we're doing here, all those types of tests there, that doesn't matter what the type of test is. whether it's a right tail, left tail, one tail, two tail. That isn't critical at this point for determining our test statistic. Now, what we do with it and where we go with it, that's where all that starts coming into play. So this is kind of background stuff getting ready for that.